Okay. So does anybody have any questions? I know I asked you to do 10, 11, 12. Those should be relatively easy, yes. So, well, if this is 4, then believe it or not, this is 4, correct? And then I think this has to be 17. And I'm trying to figure out a way. This has to be X. Wow. Anybody has anything on this? Yeah, I don't think they, I think they made a mistake on this.
Okay.
Yeah. I need to fix this for next year. Yeah, it doesn't say. Yeah, I was thinking maybe this was the right triangle over here, but but that, yeah, I don't know. Yeah, that was kind of a silly question.
I'm also confused. It's like for an angle or a side.
So I believe, and this is what I was trying to tell somebody yesterday, for if it's a degree, they'll have a degree symbol.
Oh, okay.
You know what I'm saying, right? So
Yeah.
that's how I tell kids that they should do that. But yeah. Okay, so 11, I think at first can be confusing, except they're trying to tell you that these two angles are equal, right? Do you agree with that? So if those two angles are equal, that makes that 3x, right? So then we have 6x equals what? 6x equals 90, right? So x is equal to what? 15. Does that make sense? Say it again. Because that's a triangle, right? These angles add up, right? Those angles add up to 90. Right now, what's if that's 3x, then that angle right there is 45. Do you agree? So these angles right here measure 45 degrees, right? And then this angle right here is forced to be 45, correct? And now if I'm looking, do you agree this angle right here has to be 90? Do you agree with that? And that forces this to be 45, right? Do you agree with that? Now, do you agree these triangles over here then and these triangles right here are equal? Yeah. And so this has to be 12. This has to be 12. And then it's just a squared plus b squared equals c squared. That's really hard too, guys. I didn't think it was that difficult. All right, that was really hard.
I got 849.
So So explain to me that.
I did a squared plus b squared, or 12 squared plus
Right.
y squared equals 2y squared.
Yes. I'm with you.
My calculator, that's what I got.
Right, so then 144 plus 144 is 288, right? Equals 4y squared. Let's just do the math on that, guys. That's just a good review question. All right, that's really hard. I didn't think it was that hard when I put these on there. That's really good. Now, do you see what I'm saying? Everybody understanding me? 12 squared plus 12 squared equals 4y squared, right? And then divide by 4, and what do we get? 72 equals y squared, right? I don't want to use a calculator still. Square root of both sides. So what is the square root of 72? Say it again.
No.
Remember, 72 is what times what? That's true. That's true. It's 9 times 8, but it's better 36 times 2. You agree with that?
Yeah.
And then that's 6 radical 2. Right now, again, the reason why I don't mind, or I appreciate doing that, is for those of you guys who might be taking standardized tests recently or in the future. All right, they might ask you some radical questions. You're squaring 2. Right, Harrison? I can't hear you.
Why is there so squared symbol for what?
I'm squaring 2. What's 2 squared?
4.
I'm squaring y. What's y squared? Right? All right, thank you for asking me about those. I 12 definitely is. I don't see anything about 12. This over here is a right angle. I can write a relationship between x and y, but yeah, I don't see anything on that. Okay, moving forward. Which one did I ask you to do? 19? All right. Are segments A and E parallel? Obviously, right? Because all of them are parallelograms, right? So that means this is parallel to this. Those two are parallel. These two are parallel. These are parallel. Transitive property, they're all parallel. Everybody agree? That was kind of nice. All right. Now let's check these out. Hopefully these are a little more reasonable. Do you have any questions with 20 through 25? Those are kind of easy. Yes. 20, which one?
4.
Oh yeah, so listen to me. You need to remember that these consecutive angles are supplementary, right?
Oh, yeah.
Do you remember that now?
Yeah.
All right. Anybody else have anything they want to add? I appreciate that very much. Anybody else? Anybody else? Yes, sir. Good, Nate.
On the 21.
So the diagonals of a parallelogram bisect each other. So that means this is equal to this and this is equal to this.
And then 21.
21,
Yeah.
sorry. So y is automatically what? 44 degrees, right?
Oh, okay.
And then these are consecutive, so that's 136.
Okay.
You with me? Again, sometimes I tell kids, when you're taking your test, and you'll understand what I mean when we get to it, there's so many rules, right? There are so many rules that you have to try to remember that I just never tried to remember them. All right, every single time I would go ahead and try to draw them out so you can see they're just what? Parallel lines cut by a transversal. Does everybody see that? And we've talked about that over and over. Consecutive sides are supplementary, or consecutive angles are supplementary. All right, anybody have any questions with that? Okay, so I want to get beyond that. All right, so let's do this 26 real quick. And then we'll go and do the proofs. All right, let's see how you guys are doing. Given ABCD is a parallelogram. AB is congruent to what? DC, and AD is congruent to BC, and that is because, say it again. Right, opposite sides of a parallelogram are congruent. Angle A is congruent to what? Angle C. Angle D is congruent to, and that again is opposite angles of a parallelogram are congruent. AB is parallel to DC and AD is parallel to, and then we say opposite what? Sides of a parallelogram are parallel. This is what would help yesterday for some. Angle A is supplementary to B and D. Angle C is supplementary to B and D. Okay. And then we would say consecutive sides or consecutive angles of a parallelogram are supplementary. And again, hopefully that's just obvious now. That's not good. All right, so here we go. Now you draw the diagonals. Consecutive angles of a parallelogram are supplementary. That's from our parallel lines, correct? Consecutive angles are supplementary. Okay, let's find BAC. What's true about BAC? What is it congruent to? DCA, very good. And now let's find DAC. Hold on a second. DAC is right here. So that's congruent to what? BCA. Yep, BCA. And those are actually what? Thank you very much. Alternate interior angles are congruent. And then they intersect at E, so they wanted you to put an E there. So what's true about AE? Thank you. And DE is congruent to, yeah, that, and guess how much of this we can prove? All of it. All of it can be proven. All right, all of what we just wrote can be proven. All right, and most of the time you're gonna say it can be proven because we have congruent triangles. All right, are we okay with that? We have congruent triangles. Yes, sir.
Will the last one be definition of bisect?
Y is AE. I would say here, you would just say diagonals of a parallelogram are bisect each other. Diagonals of a parallelogram bisect each other. And again, we can prove that. All right, we can prove that. Those are just things I just want you to know. Very helpful. Alternate interior angles. Alternate interior angles are congruent. And again, this is what I'm trying to say, guys. The parallelogram, sometimes it was just easier for me to just draw the extended lines. Does everybody understand what I'm saying, right? I think it's easier if you draw the extended lines to see. All right. Okay, I asked you to do 27, I think, right? So was that hard? Is that hard, guys? I don't want to spend time. If I don't have to do it, I don't want to do it. Yes. Yeah, let's try and see for you. So we know it's a parallelogram and we know DE. Let's mark DE congruent to FB. All right, now, again, I'm trying to always tell kids that you should try to make a plan before you start doing it, correct? All right, I just think that's helpful. All right, so I'm looking at this. I'm trying to prove that the triangle on the left is equal to the triangle on the right. Would you agree with that? Well, I automatically know because it's a parallelogram, what's true about CB and CA? They're congruent, right? And what's true about angle B and angle D? Do you agree with that? Right, I don't want to, you remember now, I want you to tell me, right? Is that good for you or not? I don't want you, listen, I don't want people to just shake their head. Yeah, you just told me. So yes, obviously it's true. Now you told me. I don't want that.
Could you also prove that a triangle by side?
But how do we know CF is congruent to EA is the question. Do you agree with me? I'm asking you, you want to do side, and listen, you might be right. People see things differently. If you can tell me why EA is congruent to CF, I'm happy with side. But you have to tell me why. You understand what I'm saying? I'm not saying you're wrong. I'm saying in order to prove side, you have to tell me why EA is congruent to CF. Is there a way that you know of? Right? Are you with me? Are you with me?
Yeah.
Okay, because I don't want, I want you to tell me. So do you agree now it's just side angle side? All right. And now we can prove angle 1 is congruent to angle 2 by what? Yeah, CPCTC. All right. How's that, Abigail? You good? All right. Maren, what were you asking? What? But they're not. Do you agree?
Yeah.
Right. It's telling you parallelogram ABCD, right? Now listen, because I feel like this is a really great question. Maren brings up a great point. Can someone tell me, is ECFA a parallelogram? Well, how do we know that? Come on. How do we know that now? Is EA congruent to CF? Well, you can definitely, we now definitely know it's true because why? Yes. So now we know this is congruent to this by CPCTC, right? Does everybody agree? Now, is it true that EC is congruent to AF? Do we agree with that? And does anyone want to tell me how we know that? Tell me.
Because DC is congruent to AB and DE is congruent to FB. So if you subtract them both.
Yeah, exactly right. We could do the segment addition postulate, subtract 2 equals. So we know that's true, right? So now, do we know that ECFA is a parallelogram? And why do we know it's a parallelogram when we haven't said anything true about the parallel? What did we just say about the opposite sides of a parallelogram? So if the opposite sides are congruent, then it is a, that's how you know. It's called the converse, right? So if the opposite sides are congruent, then the angles, or then the quadrilateral is a parallelogram. All right, does anybody else have any questions with that? All right, I think that's pretty good. So let's knock out 28, guys. All right, so I'm trying to prove AEB is congruent to CED. So I'm trying to prove the top triangles are congruent. Now look, this is kind of easy. All right, super easy as a matter of fact. All right, we already know it. There's several options here. There are several options. So let's just put the given in. All right. All right, well, give me one thing.
DC is congruent to AB.
DC is congruent to AB. Why is that?
Opposite sides of the parallelogram are congruent.
Opposite sides of a parallelogram are congruent. James,
Angle AEB is congruent to angle CED with the vertical angle there.
angle A, say it again.
Angle AEB is congruent to angle CED.
You're awesome. That's true. Right, so now let's do that. So we have angle DEC congruent to angle BEA. Vertical angle theorem. All right. So now we have to use that information. We have to use that information that's given. There's lots of other ways to do it, but we're using that information. So I need someone else to tell me now, what do I know using that information? Lexi.
Could you do CBE is congruent to ABE because they're alternate interiors?
Exactly. Very good. So this angle over here is equal to this angle over here. And that's what?
Alternate interiors.
Alternate interior angles. Angle CDE is congruent to angle EBA. And that is, again, alternate interior angles. And so now what? What's true, guys? By side angle angle. Or angle angle side. Either way. Everybody good with that? Now, if James didn't do the vertical angles, we could have also said, this is why I'm just showing you something. We could have also said this angle over here is the same as this angle over here, and now it'd be what? Angle side angle. We could have also said that, and this is why I'm trying to tell you, don't think you're wrong just because you do it differently. All right, if you're not sure if you're right, you can ask me, but these two are equal, right? And these two are equal. So now it's what? There's a million ways you can prove that. All right, don't make it difficult. Parallelograms, something that's hidden in parallelograms a lot is alternate interior angles. So I want you to try to remember that if you come to a tougher proof. Alternate interior angles, you need to remember that. All right, let's continue on. All right, let's check out 29. All right, I think I like this one a little bit. All right, so let's go ahead and mark the given. All right, now HP, I got to find HP, is congruent to JQ. I'm trying to prove, and I'll highlight that, PX I'm trying to prove that this is congruent to this. That's what I'm trying to prove. So if that's going to be proven true, probably what am I going to have to do? Yeah, but listen to what I'm saying. I'm not trying to do the proof right now.
Oh.
Right. What I'm trying to do is I think I know I struggle with proofs. All right. What you go do them in college. It's a lot of fun. All right. But right now, I'm just saying to myself, for some of you guys who've struggled, is the first thing you have to do is not try to write the proof, but just say, what should I try to do to prove it? And what should I try to do?
Triangle PXG is congruent to XQ.
Yeah, that's what I think you should do. Right? Your job is to try to prove those triangles are congruent. And then if you prove those triangles congruent, then the parts are congruent, which is easy. All right. That's where I'm trying to help some of you. All right. We're not just looking at this going, wow, that's obviously true. All right. You should have some kind of a game plan. And so the game plan is to try to prove that those two triangles are congruent. And then we know that the parts are congruent. All right. So that's our objective. All right. So now we have to go about doing that. So Maren, give me the first step. Yes, ma'am. Very good. Angle PGX is congruent to what? QIX. And those are alternate interior angles. So that's one piece of the puzzle. That's one piece of the puzzle. Alternate interior angles. And I truly believe it's easy. And those of you guys have been struggling a little bit. I prefer to hear from you than from everybody else. All right. Will.
QXI is congruent.
Hold on a minute. QXI. Okay, I like that.
Is congruent to PXG.
So angle QXI is congruent to angle PXG. Is that what you said?
Yes, sir.
PXG. And again, that's what?
Vertical angle theorem.
Vertical angle theorem. Look how easy this is. 2 marks. 2 marks. All right, guys. Almost there. All right, someone else. Someone else. Catherine, find something. Okay, Nate, jump in.
QI is congruent to PG.
QI is, say it again now.
QI is congruent to PG.
Tell me why. That's true, but it's going to take some steps. Why is that true?
I figured it out because of the given.
Well, it's kind of like we said earlier. Right? You're correct. That's definitely true. All right, we definitely have to know that. But this is the annoying part. Right? Harrison, tell me.
You have to say that GH is congruent to J.
Yeah, the first thing is, right, this is the annoying part of this proof. This is like another, how many steps? Probably 3 or 4 steps. All right, it's going to take another 3 or 4 steps. All right, so we're going to say that, first of all, come on, we can do this, that we know that GH is congruent to JI. Now, is there, I need to prove a side, right? Because it's never angle, 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 right? So is there a way to say that XG is congruent to XI?
Because they're the diagonals, so they're bisect.
You know what? I almost said that myself. But tell her what's wrong.
Because PQ is not the diagonal.
Yeah, you see what I'm saying? That's why I was thinking earlier. I was like, yeah, that's just so easy. Just make that right. But does everybody see the flaw, right? I almost said that too. PQ is not a what? It's not a diagonal, right? Because it's not a diagonal, we don't know that it bisects it. All right, so that's kind of annoying. All right, so once I knew I couldn't figure that one out, then I was left with either PX and XQ, which is what we're trying to prove. But then I realized that's what we're trying to prove, so that's not there. So the only other option is PG has to be congruent to QI. So with that being said, GH is equal to JI because why? Yeah, opposite sides of a parallelogram are congruent. Okay, so then from there, all right. From there, what do I need to say? Tell me. Yes, that's what I have to say. And number 5, I'm going to list it twice because it's the same thing. So GP plus PH equals GH, and JQ plus QI equals JI. Is everybody okay with that? And we have to go way back to the beginning of school. What's that? Help me. Yay, good job, girl. Segment addition postulate. Segment addition postulate. All right, is everybody good with that? Anybody? All right. So now, what can we do? What about step number 6? Yeah, tell me. Come on, good job. Yeah, we could say that. I think it's a little. Okay, so what would you like me to write? No. I think you should do one more thing before that, but you could do it out of order. It wouldn't matter. I think you should say what?
GP plus PH equals JQ.
Yeah, that's what I think. GP plus PH equals JQ plus QI. And then that's the what?
Substitution.
Yeah, that's the substitution. And now Harrison, what? GP is congruent to what? Well, how do we know that? But I have to do what with pH? Make it what? You said it the step before this. Tell him. Yeah, but what do I replace pH with? Or HP? JQ, right? So GP plus JQ equals JQ plus QI. You agree with that? That's also what? Substitution. Now what do I know? GP is equal to or congruent to QI. Right? And why is that? Yeah, we did the subtraction property. Now hold on. I do want to go back to make it equal, just to be formal, just to make sure you guys remember this. So number 9, now they were equal. Now you say they're congruent, right? I don't really care if you left that step out. That's definition of congruence. So now we know GP is congruent to QI. So now we can mark that. So now what's true? I'm taking your word for it. Tell me what it is.
Wait.
Triangle.
No. Press that. Triangle PGX
Is congruent to triangle.
QIX.
Anybody agree with that? Do I need to? Come on, guys. Is that true?
Yeah.
PGX Q, I like it. And why is that?
Side angle.
Yes. And now what?
PX is congruent to QX.
And that is,
CPCTC.
wow, guys. That was pretty nice. Really nice, actually. All right, finally get to a proof that's more than just repeating information. You had to think on your own a little bit. All right, very tough. What?
Why couldn't you just said that PQ is congruent to PQ?
Well, what part of the triangle is that?
I thought it was a side for both triangles.
Yeah, but here, listen, buddy. So this, what I'll do for you is I'll try to show you this. This right here is not a side of any of the triangles. It's so this is part of the triangle or part of the side. Is that clear? All right. Really nice, really nice. Okay, here we go. Let's have some more fun. Okay, so let's mark them now. All right, let's go back and mark the figures. And then let's try to make a plan. Angle 3 is congruent to angle 4. MW is congruent to SN. I have a feeling this is the same thing almost. So I'm trying to prove IM congruent to LN. Is this the same one, essentially, in my opinion? Is that the same thing, right? Because what are we going to have to prove? The triangles are congruent. And then what's true about angle 2 and angle 1? And how do I know that MB is congruent to NO? What? Yeah, exactly the same thing we did up here. Right, is everybody okay with that? Exact same. Tell me.
Couldn't you prove that triangle
Triangle what? Say it again.
SBO is congruent to triangle WOB?
Okay, so how does that help me with those triangles? Because we definitely know angle 1 is congruent to angle 2. So I need a side. So what side would that help me get? Do you agree with me? What's in it? I'm asking again. I'm trying to tell you guys, when you ask me a question, I don't have all the answers, right? I'm trying to get you to tell me how does, because didn't you say this triangle right here, right? And this triangle here, right? So how does that give me a side is my question. You see what I'm saying? Right? That's definitely true. All right, 100% true. But I don't know how that, because our goal, remember, is to make this triangle equal to this triangle, and then IM is congruent to NL by CPCTC. So I need to prove something. All right. I need to prove something is congruent, a side that is congruent. So I think the only way is this. So you guys can redo that proof. All right, because doing that proof is the same as doing number 29, just to make sure you're good. All right, now let's do this one that's supposed to be a challenge. I don't know if I would agree with that necessarily, right? So we know DE is perpendicular to AF, so I'm going to mark that. And CF is perpendicular to AF. So that's true, correct? Prove that DE is congruent to why would anybody say that's hard? Prove, hold on. Prove this is congruent to this. Am I right? That's what it says, right? We know this is parallel to this. Well, I don't even have to do that. We know that ABCD, so I automatically know that's congruent to that, right? All right.
What angle A and CDF is corresponding?
Well, I'm gonna do this. Was there anything else I left out? 27. Okay, so let's go back and do this. Since that's a challenge, I'm gonna sit and try to do it. I'm gonna see how challenging it is because it didn't look too hard to me. But you guys finish up. 17, 18. Wow, time flies when you're having fun. All right, so finish everything up. Tomorrow, I especially want to look at 31. Listen, everybody make sure you get 31 done. Hint, everyone make sure you get 31 done. All right, I'm gonna collect it tomorrow and I'll look at it. All right, but understand, I don't want you just copying someone's down because you don't know how to do it. All right, try it on your own. All right, try it on your own and then hand it in. Yeah, I want you to do 30. 30 is kind of easy though. 30 is just like 29. All right, and then I'll take a look at 31 and give you, give you some credit for 31 since it's a challenge supposedly. All right, good job today, guys. I appreciate it. And now I get to